Remember Jonathan Pangborn, the guy who suffered paraplegia and lost control of his legs in the movie Doctor Strange? He was able to walk again by channeling dimensional energy directly through his body, which is a highly fictional concept. However, what if I told you this is possible in real life, without the requirement of magic, of course? Welcome to the science of neuroplasticity. Neuroplasticity is the brain's ability to change and adapt throughout the course of its life. Now, this may seem like a rare phenomenon that's been unheard of, but this occurs every day right under our noses and is commonly known as something else. Learning. You learn something, your brain forms multiple neural connections in the temporal lobe of the brain. This is because there's an organ called the hippocampus, which is responsible for holding most of your memory. So if you learn a new skill like riding your bike, then you'll form new connections in your brain, and as you practice more, you'll form even more connections. The more connections you form, the more you'll tend to remember it, and eventually you'll get better at it. That's why people say practice makes perfect. However, if you don't practice something regularly, then the neural connections formed start to get weaker and weaker until eventually they break. When this happens, you slowly start to forget the skill or memory. This is basically how people learn and forget, but this has an effect in the brain as well. When you learn, due to the increase in connections formed, a part of the brain called gray matter starts to expand. Gray matter is basically the cell bodies of nerve cells or neurons. This is where the information you learn is stored. When you forget something, the gray matter starts to shrink since the connections start to break. However, it'll only shrink a little, as your brain will still remember the memory or skill even if you don't. This type of plasticity is called structural plasticity, as the size and structure of the brain changes when the gray matter expands. Even though neuroplasticity happens every day in our daily lives, there are some extreme cases as well. Here's an example. A long time ago, there was a tennis player, and this tennis player was good. But unfortunately, he suffered a stroke and the cells in the part of his brain that controls his left hand were killed. So for the next few months, he wasn't able to control his left hand. However, a while later, he was playing tennis with his left hand as if nothing ever happened. How? His doctor immobilized his right hand and repetitively encouraged him to use his left hand, even though he couldn't. Since the cells that control his left hand were killed, the area of the brain had been rendered useless, and because he kept trying, the function was eventually transferred to a group of healthy neurons nearby, which were capable of controlling his left arm. By the end of his treatment, the function of controlling his left hand had been completely transferred, and the tennis player had control of his hand once again. Now, this phenomenon is quite rare and takes a lot of willpower for it to work. It's basically neuroplasticity on the largest scale, as entire brain functions are being transferred across the brain. Now, this type of neuroplasticity is called functional plasticity, as entire functions are being transferred in this case. Well, reaching the end of this video, so let me summarize all that info. Neuroplasticity is the ability of the brain to change or adapt throughout the course of its life. Structural plasticity is when the brain's size is affected due to the expansion of gray matter. And functional plasticity is when functions are transferred across the brain. This is the science of neuroplasticity.